Hello, and welcome to Recitation 0 for Fall 2019 Introduction to Deep Learning. My name is Hannah Mazum, and I will be going through part 1 of this recitation. It is split into 3 parts, with part 1 going over Python skills and libraries, part 2 going into depth with the Python library NumPy, and part 3 going over different platforms which will be helpful for you while doing assignments throughout the semester. All 3 parts will be useful for you, not only for Homework 0, but for all of the assignments during the semester. In part 1, we will be going over Python, modules, file formats, loading data and storing data, list functions such as filtering, slicing, and comprehensions. We'll be considering 1D, 2D, and 3D arrays. We will look at classes, and we will look at debugging using PDB. Lastly, we will cover some activation functions which will help you complete Homework 0. The homeworks in the course will all be in Python, and we recommend downloading it from the given link. This link also contains links to all the documentation for Python with information on all the different libraries and functions available. We recommend Python 3. The latest version of Python 3 should be available for download. Now let's look at modules in Python. To be able to install modules, we will be using the pip package manager, which you can download over here. The primary modules that we'll be using during the course will be NumPy and PyTorch. However, others of course may be useful and may be necessary. A module is basically a library containing functions which help us with different implementations. For example, there is the math library in Python which contains different mathematical functions. There are different ways of importing modules, and we will cover them over here. The first one is if we directly import the module by name. For example, we're importing NumPy. When we do so, to use a function within the NumPy library, we need to reference the function from NumPy. For example, here we're creating a NumPy array. If in such a case where the name is long, we can shorten this and give it an alias such as NP over here. NP is the most standard usage for NumPy, and we can then specify our array in this format. Another way for importing modules is if you have a specific function that you'll be using from a module, you can specify that function itself rather than importing unnecessary things. And lastly, this syntax allows you to import all of the functions and allows you to use them without referencing math itself in this example. This is not an optimal method because this can cause conflicts between modules which have functions of the same name. So these methods are preferred. Now we'll move on to file formats and loading data. Here is the list of the most common file formats you will come across. The .txt extension is for plain text files. .pkl refers to Python objects. We will talk about these in just a few minutes. .csv is for comma-separated values, which is for tabular data. .npz is a zipped archive of npy files, where npy files are NumPy arrays, which have been saved using the NumPy library. When we are trying to read from a file, we need to first open the file in Python and then specify that we want to read permission. In the case of writing to a file, you would have to specify for write permission. All these different permissions are listed along with the considerations that need to be made for that permission on the Python documentation we referenced above. Here is an example of a function we can do on files, which is called readLines. What it does is it reads the lines in a file and returns a list of those lines. Also, something important to note here is that we must remember to close our file object, because if we do not close our file object, then the file will remain locked and will not be able to be accessed by someone else. Another method for accessing files is to say with open as f. What this does is it saves you having to write the line f.close, because it's ensuring that while this is open, we run this function, and then once this is done, we are no longer within the with open statement, hence the file object connection is closed. There is some more information about file functions and access modes in the Stack Overflow post, which I would recommend you look at. Now, remember we mentioned the .pkl file extension? That is generated usually through this Pickle library in Python. Pickle is a library for serializing and deserializing Python objects. What this means is it allows us to store Python objects in a format so that they can be loaded back into Python programs without any conflict in terms of the structure or the representation. So for example here, if I create a dictionary in Python of students and their names, and then I want to save this dictionary to my disk to use later, I will use pickle.dump with the name of my object, and I will open the file location that I want to store it in, and this again is the permission that I am giving it. Now once this is done, when I later want to come to use it, I will have to use the pickle load function, now specifying the same file name, but note the difference in the permission in the file access. So if we run this, we can see that I've printed my loaded dictionary, which is the same one which I dumped out. Typically these files are given a .pkl extension. For CSVs, we have a sample data CSV file provided to you with this notebook, which is for crime in Sacramento. Now here you have a CSV reader, which is part of the CSV module, and this allows you to specify the delimiter, because it could have been tab separated as well. The CSV library covers different tabular data. And here what I am simply doing is printing out the first 10 rows in our file, and this looks as follows. So you can see the heading in the first row, and then the following rows contain different data for crime in Sacramento. Now we move on to storing data. There are different types of data structures in Python. You've already seen dictionaries when we were talking about Pickle. We'll discuss them in more detail here as well. So there are lists, which are generic containers and allow you to index. Basically, they allow you to access the objects within it by specifying its index. There are tuples, which are the same as lists except they're immutable, meaning they cannot be changed once they've been created. There are dictionaries, where the keys act as indices and the keys must be unique. And sets are a group of unique elements. So if we look at lists, lists can be heterogeneous. They do not need to contain objects all of the same data type. So we can have both of these two lists are valid. Now we can access lists by indexing, as we mentioned, and we can find the length of the list so we can loop over it, etc. We can change values within a list, which is over here, and we can access the values in the list. So if we run this block of code, we see that we access the same type at index 3, so 0, 1, 2, 3 gave us 89, and then the length of our list was 7. We replaced index 0 in the same type list, so now this is our new list, And our last statement threw an error because we were trying to index outside of the length of the list. Hence, it's complaining that the list index is out of range. Now, if we can also combine two lists by essentially adding them together, which concatenates them. So in this case, we can see our output is our two lists over here joined together one after the other in the order we specified. You can also multiply lists, and what this does is it basically copies the elements in the list the number of times we multiply. If we look at tuples now, we can, as we did before in lists, we can access objects in the tuple by index. Again, tuples as well can be heterogeneous, but see what happens when we try to assign a value to a specific index in the tuple. We get an error saying that the tuple does not support item assignment. As we said, tuples are immutable. Now let's look at dictionaries. A dictionary, as we said, has keys and values. So in this dictionary example here, the keys are the student numbers, student 1, student 2, and student 3. And then the values are the names of those students. We can access the values by specifying the keys. So there are two ways of doing this. There is the format we would use for lists indexing with the square brackets, and then there's the get function. The get function allows you to specify a default value to return if the value requested is not found. So in this case, as you can see, there is no student 4 in this list. When we run this block of code, we see that for student 1 we get Alice. For student 4 over here, we get it throws an error that the student that the key does not exist. We get a key error. If we comment this line out and try our get function, we get our default answer of that the student does not exist. So the get is normally safer and less error prone to use. Now we can assign new names, in our case names and students, but we're basically assigning a new value to the key student 1 in this block of code. So after this, when we print our dictionary out again, student 1 now has the name Billy. Similarly, sets must also contain unique elements. So if we have a set over here of these 3 objects, we can see when we print it out, it looks like this. However, something interesting about sets and dictionaries is that the order does not matter. They're unordered. So if we index the set at index 1, it tells us that the set does not support indexing, because the order in a set and dictionary is irrelevant. Some other list and tuple functions which you might find useful, as well as of course you're welcome to explore the documentation, are max, min, and sorted, which are pretty self-explanatory. We can manipulate lists in a number of different ways. We'll be looking at slicing and dicing and list comprehensions, and we'll look at these for 1D and 3D arrays. So the general format for slicing is to specify within square brackets the start index, the end index plus 1, because what you specify here after the first semicolon is non-inclusive. And then we have a semicolon and step. Now, colon. With this example list over here, we'll look at different types of slicing. So if you see here, when I said 5 colon and close the brackets. What this means is I'm specifying the start index and I'm saying go until the end of the list because I'm not specifying an end index or a step. So we went from index 5 all the way to the end. Conversely, I can specify the index to stop at, but starting from the beginning. So here it went up to index 2 because this is non-inclusive. So we had 0, 1, 2 over here. And then finally, we could have specified all three of them, where step just means how many elements you're skipping. So in this case, we start from index 3, 0, 1, 2, 3, and we have a step of 2. So we skip this element and we reach this one, and we skip this element and we reach this one, and our end index is 9, so we don't go past 80. Now if we look at 2D and 3D arrays, the slicing operation is a little bit more complex, but the idea is the same. So when we have a 3D array, the way we index across the 3 dimensions is as follows. We have I going across the different matrices. We have J going down the rows. And we have K going across the columns. So you would need to think of your 3D matrix as a block of matrices. Now, I've initialized here an example 3-dimensional array, which is represented by this image here. So we'll initialize this array, and now we'll look at the case when we want to select a specific row in this array. Now, I want to be able to access the row, I would first need to specify the matrix that I'm in. For example, here, if I want row 2 in matrix 0, I will first specify matrix 0 and then row 2. And then this should give me 16, 17, 18 over here. Similarly, for selecting a column, I have to specify the matrix, ignore excuse me, sorry, there's an error here. So we would specify the matrix, ignore the row, and then specify the column because we're going I, J, K. So to select column 1 in matrix 1, I would use this syntax where the colon means take everything here, and I'm specifying these. So when we run this, we get 21, 24, 27, which you can see here corresponds over to our 21, 24, 27, which would be in this diagram in matrix number 1, this this column, this first column. Now, if we want to simply select the entire matrix, we only need to enter in the first number. So I can get matrix 2, which is all the 30s, in this way. Now, what if you want to access a row across matrices? What if you want data from multiple matrices? We can access that in the following way, where we say that for all the matrices, I want the elements in row 1 and column 2, for example. And then that gives us this set of elements, which if we look over here, is going back this way. Similarly, we can create a matrix from the rows in which we would say we want, for every matrix, we want row 1. So now we would have an output which is 2-dimensional. And lastly, we'll look at creating a matrix from columns, which is similar syntax to the previous example, except now you have to also say you want all the rows. So, and you specify the column number. So you would get another 2D array. You can also slice within rows, columns, and matrices in a 3D array, and the syntax would be the exact same as what we did for 1D arrays. Now we'll look at list comprehensions. List comprehensions are important because they are more efficient than for loops in Python, so they can help you optimize your code. Functionally they do the same thing as a for loop. However, Python is internally optimized for comprehensions, and we can compare the time taken over here. The format is as shown. We write the expression and the conditions in square brackets. So for example, we would say number for all the numbers in our list if it is an instance of int. Because if you remember, we added to index 0 we inserted as piece of string. So we want to basically see all the positive numbers in our list, which is the output that we received. Now if we time the difference between using list comprehension and a for loop, we'll see a significant difference. This took 22.1 microseconds, and this one is almost twice as much, more than twice. So you can see how this can help you optimize your code when you have large comprehensions to do, or like larger pieces of data to process. Now we will look at classes. Classes will be very important for homeworks throughout the semester. You will be using classes to define your neural network models, for defining data sets. So we'll look at an example of implementing a dataset class here. So from the Torch library, we import this dataset class, and what we do is we inherit from the functions of the class and we define them as per our needs. So for example, if my dataset contains objects and their labels, the objects being X and the labels being Y, I would want to save these as attributes of my class so that I can access them later. So this would be in the init function. In the init function you would specify all of your basic parameters and make them attributes of the object. Then you have the getItem function, which you need to implement, and basically that is specifying how you index into your dataset. So if an index is passed in, what do you return back? In our example here, we're returning back the X value and the Y value at that index as a tuple. The third method that you must implement is the length method, which is to specify how the size of your dataset is determined. And in our case, in our example, we are simply returning the length of our inputs, because this will be the same as the length of Y. Finally, we'll look at PDB. PDB will be very useful to you when you're debugging large pieces of code, because it allows you to set breakpoints and then step through your code. For example, if we look here, we have for loop, and if I had a bug in this for loop, I could write pdb.setTrace, and then when I run my code, it will ask me, it will stop when it reaches this line. And there are different ways to go through your code. There's a number of other functions, but the main ones that you will be using are step and next. You can type them in as just S or N. Step stops within the called function, whereas next will stop at the next line of the current function. So suppose you're using a library function, step will go within that function, whereas next will stop only at your next line. So if over here we say next, you can see that it's reached the next line and it's saying this is iteration 0. and it's pointing to what the next line it's going to execute is. Now if we continue in the following way, you can see the output at every single iteration, and that allows you to go through your code more systematically and identify bugs more easily. Now we'll briefly go over two activation functions which you will be implementing in homework 0. Artificial neural networks are modeled around the way neurons function in the brain. The way neurons function is they need a threshold value to be able to learn whether a signal is important or not. So this is the idea that we're trying to implement in our neural networks. And that's where the need for an activation function comes in, because we need to somehow specify when our model needs to pay attention to the inputs. There is of course a lot more background and detail to activation functions, but this is the general concept that you need to understand to be able to do homework 0. So this is the first activation function that we're looking at. This is the ReLU. As you can see here from the graph, the ReLU does not output any signals when the input is negative. As soon as the input is positive, then it is a linear graph where as the signal increases, the output from the ReLU increases. The next one is ReLU prime, which is always 0 when negative, same as ReLU. However, for the positive cases, please note that this should be a vertical line. There should not be a curve, it's just the way the graph is represented. And in the positive cases, there is not a positive correlation. It is always 1, regardless of the intensity of the input. That's the main difference between ReLU and ReLU prime. These are the two activation functions that you will be implementing in homework 0. That is the end of Recitation 0 Part 1. Please continue watching the next two parts, and good luck with the homework.